we're going to review two kind of units today, all right? We're going to look at the systems unit. We'll look also back at the exponential unit too, okay? And talk about those. So yeah, let's get into this thing here today. All right, so first of all, right, we just want to remember how to solve systems, okay? When it comes to solving systems of equations, we have three methods, okay? Well, actually four methods, I guess I should say. My apologies, because you also have the matrices too. All right, so what's one way that we have to solve systems of equations? What's one of the methods' names? Do you remember? We could graph. Okay, Olivia? Substitute, yeah, or substitution. Alessandro? What's that? Yeah, and I'm going to call that one elimination, but that's the idea, is that they do like kind of eliminate by combining them together. And then I also mentioned the matrices too. Okay. Okay, so let me zoom in here on number one. Now, we have, four different ways to solve these. And why do we have four different ways? Oh, question, Jackson. Okay. We have four different ways to solve these because some are better fits for certain kinds of situations. So, Jackson, were you going to say like what method would be good here? Okay, which one do you think would you like to use here, maybe? Yep. Yeah, exactly right. So number one, Jackson looks at that and says, well, Mr. Whitmire, I'm guessing you like graphing there, Jackson, because you already have one that's solved for y, so you might as well just solve the other one for y and then graph it. Is that what you were thinking? Yeah, so that's perfectly fine, right? One option that we have here, okay, is that we could just solve the top equation for y. We could graph it and then graph the second one and then just find their point at intersection. So that's, sorry, I got you, Trey. That's one option here, okay? That's one option. Okay. What other strategy is this number one suited for as well? So graphing would be a good one, I think. What other one would be a good one for this one? Yeah, substitution. And Anna, what kind of clues us in here about why substitution is a good one? Yeah. Exactly. Okay, so that y, we already have solved for one variable here. So 5x plus 4 is y, which means this y right here, I could plug in a 5x plus 4 and then, simplify and solve for x. Okay, so I'll kind of show you both ways here. All right, let's solve this one for y first. So I'll try and squeeze that in right here. So we have 10x minus 2y equals 4. Okay, to get the y by itself here, what do we need to do to both sides? Subtract 10x from both sides. Okay, then have negative 2y equals 4 minus 10x. Okay, and then to get the y by itself, what do we do to both sides now? Divide both sides by negative 2. So I'm going to run out of space here. I'll just put it up here. And so negative 2y divided by 2 is going to be y. Negative 2, I should say. 4 divided by negative 2 will be negative 2. And then negative 10 divided by 2 is positive 5. Okay, so there's our other equation. Now, some of you might be able to look at this result and right away tell me what the answer is going to be. What do you notice about these two equations? They have the same slope, 5x, but different y-intercepts. If you have the same slope but different y-intercepts, that means these lines are parallel. So where will they intersect? Never. So that means we have no solution. Okay, what's that? Are you looking at the next one? I got you. Okay. No solution there. Okay. Let me show you with Anna's method real quick here using substitution, and I'll show you how that works out as well. So let's say instead that we talked about doing what Anna said there, we could substitute, okay, the 5x plus 4 in for the y. All right. So I'll plug in, we have the 10x still, minus 2, but like I said, instead of the y, I'm going to put in 5x plus 4, okay? And that's equal to 4. Okay, so you see here, this y right here, I plugged in a 5x plus 4. Okay, and now well, how can I go about continuing here? What should I do next to continue my work here? Distribute the negative 2, very good. And so we'll have 10x minus, 2 times 5 is 10. And then negative 2 times 4 is negative 8. Okay. Now, what can we do next? Combine like terms. And when I combine 10x and the minus 10x, what happens? It's 0. They exactly cancel. And so I'm going to have negative 8 equals 4. But when does negative 8 equal 4? Never. So that's why we go to the no solution answer there. Okay? Question? Oh, I'm sorry. All righty. So yeah, no solution is our answer there. All right, so there's that one. Questions on number 1? Kind of a mess there with all the work that I did, but you get the idea. All right, let's take a look at number 2. Okay, so number 2, is this one set up nicely for substitution? No, not really. Why not? Yeah, it doesn't have y equals or doesn't have x equals, right? If it was solved for a variable, if one of these was solved for a variable, then we would be like, yeah, let's use substitution here. But nah, probably not. Is it set up for graphing? No, because again, it's not in a form that we can graph, right? It needs to be y equals and y equals for us to graph it. We could graph it, right? We could solve both of these for y and graph them. That's an option. But the way this is set up, it's really nice to set up for which method here? Elimination. Or matrices, if you remember how to do the matrices stuff. But I'm not going to encourage, you can do the matrices stuff if you want to, but that's like one more calculator skill. I don't want to give us too many of those, so let's do elimination. Okay, so right now, if I add these two equations together, will the variables cancel out? No. What's that? What can I do to this top equation so that when I add them, they will cancel? What do I want to multiply the top equation by? Yeah, let's do negative 2, right? I can see here that right here, let's say we're going to eliminate the x's, okay? To make this 2x the opposite of 4x, I would multiply this by negative 2. So I'll multiply both sides of the equation by a negative 2 here. So I'll actually end up with negative 4x plus negative 2y equals negative 10. And then I have the positive 4x, positive 2y equals positive 10, right? Because that's the bottom right there. So yeah, and then Grayson saw exactly what's going to happen here. Okay. Combine them, yep, then we add them. Now, what's going to happen? Negative 4x and 4x makes, they're gone. Negative 2y plus 2y? 0. So I get 0 on the left-hand side. What's negative 10 plus 10? 0. Okay. When does 0 equal 0? Always. So is this no solution?
It's infinite.
It's infinite solutions. Infinite solutions. So it means, there's an infinite number of solutions. It doesn't mean that any solution works. It does not mean that any solution works. It just means there are infinite solutions. Okay? If we were to graph this, what would our two lines look like? They'd be the exact same line. Okay? They'd be the exact same line. They would overlap exactly. Okay? All right. So questions on 1 or 2 there. So we use elimination here. That was just some practice with that. This is a good elimination method there. And then we use substitution here. Okay. Sorry, I know that's like really messy over there on the left-hand side, but you get the idea, right? Hopefully yours looks better than mine. Okay. Questions on 1 or 2? So now we'll do the third one here, which is also solving a system, but we're going to solve it by graphing because it asks us to graph, right? So it says to use a straight edge. I think we can get away without using a straight edge here. Let's see, okay? So that first equation, do we need to do anything to it? No, it's in slope-intercept form. What is the slope of that first line? Yeah, very good, negative 1 over 2. Great job, Trey. What's the y-intercept here? Negative 1. Yeah, be careful. B is negative 1 there. So let's go ahead and graph that line. Okay. Where do I start on my coordinate plane here? -1 on the y-axis. Please make sure, folks, you do it on the y-axis. Okay, -1 on the y-axis. Okay, and then what does my slope tell me to do from there? So we can go down 1, right 2. And I'll just keep going down 1, right 2, down right 2, down right 2, down right 2. Or we can go up 1, left 2. Very good. Up 1, left 2, up 1, left 2, up 1, left 2, up 1, left 2. Okay, and so there's my line. I'll go ahead and connect these dots. No, the test is Thursday, Friday, and Monday.
Tuesday.
Thursday, Friday, and Tuesday. That's right. That's right. You guys get to go have some delicious food Memorial Day and come back and test. Okay? All right, so there's one of our lines. But now we got to graph the second line. Is this second line in a format that we can graph easily? It is not. But what's one thing we could do here? How can we get this in a format we can graph? Okay, so subtract 3x on both sides. Minus 3x. Divide everything by -2. Yeah, so -6 divided by -2 is 3. -3 divided by -2, +3/2. Or yeah, that's fine too. 3/2, 3/2. Okay. Okay. Super important here. We can get that slope-intercept form. Very important. Okay. All right. So, what is the y-intercept of this line? 3. What's the slope of this line? 3/2, 3/2, yeah. Okay. All right, so going to our graph here, where do we start? 3 on the y-axis, 1, 2, 3. Okay, and then from here we're going to go up 3 over 2, up 3, right 2, or down 3, left 2. Up, there is our point of intersection. Okay, there's our point of intersection. So what is the solution? -2, 0. You got it. Okay? Now this is interesting. Part C says justify your solution using mathematics. So how could we justify our solution here? What kind of way could we use to prove it's the solution to this system? What's one thing we could do? Sky? Okay, so what do you mean by show your work and use substitution? Like, how would you show that's a solution by using that?
You plug in y for the body equation, and then do the other steps for substitution.
Ah, I see what you're saying. So you're saying solve this another way, maybe using substitution or something like that, and then show that you get the same answer there as the point of intersection.
Yes.
That's one way to do it. Okay, that'd be another way. Alessandra, your bathroom. Yeah. Anna? Yeah, it's another method here too. Did you hear that one, Sky? So that way, so Anna's saying you could plug -2 in for your x value, 0 in for your y value, and just show that you get a true equation. That's another way to justify it here too. So I'm going to show it that way just because we haven't shown that yet. So in other words, it's basically just like checking your work. We're going to plug 0 in for the y. We'll plug -2 in for x. And we'll show here, well, -2 times -1/2 is going to give me a +1. And then 1 take away 1 is 0. So 0 equals 0. Check. Okay. Simultaneously, we have the, oh wait, actually I should say here, is that enough to prove that -2, 0 is the solution here? No. What else do I need to do? I got to plug into the other equation here. So 3 and then -2 in for x and then 0 in for y. like that. So you have to check both equations to justify here. 3 times negative 2 is negative 6. Negative 2 times 0 is going to be 0, so I get negative 6 equals negative 6. Check, it works. Okay, so there's the justification. The point, our solution point, works in the first and the second equation. So that's how we know it's right. All right, questions on part C? All right, I want you guys to go ahead then, try number 4. Okay, this one is an inequality. All right, this one's an inequality, so remember what you need to do. Think about dotted versus solid lines. Think about where you're going to shade, above or below, you know, what region and stuff like that. So go ahead and try this one, all right? I'll give you like a minute or two there to try that one, number 4. Okay, and then we'll go through it together. So try number 4 on your own there. See what you can remember, okay, about the systems. Okay? We kind of talked about this, I think, on Thursday of last week. I'm pretty sure we talked Thursday or Wednesday of last week. Graphing systems. So go ahead, try number 4, okay? Graph your borderline, make it solid or dotted, and then shade. Find the right region for your graph. Okay? Find the right region there for your graph. Try number 4. Try number 4. Okay? Try number 4. Okay? You sure? Yes. Yes, go ahead. Yes, that looks good. Now you can graph it, right? That's what you're make sure you can graph it. Think of solid or dotted. Think about which one you're going to do. Make sure you don't count right. When you divide by a negative, yes, you flip your inequality. Oh wait, when you divide, you don't. No. Sorry. Hang on. Don't. Oh yeah. So you're. Yes, when you multiply or divide by a negative on both sides, then it flips. Otherwise, it stays the same. Did you say you weren't sure about how to graph it? Careful. That is the x-intercept. That is supposed to be the y-intercept. So when you divide here, like how much slope remains. Okay, yeah. Be very careful with that. Y-intercept. We always go first. B is the y-intercept. Sure, yeah. Jasmine, you join the cameras? Yeah, you're on the right track. Yeah. Do you have contacts? Okay, we can splash some water in or something. Yeah, you're on the right track. Graph. Okay. One more minute here, folks. One more minute. We're going to go over this.
This one where we like embrace this part, right?
So you're going to decide which one are you graphing this one here right now. So then you want to shade. You want first of all do this use solid or dotted. So it's solid. So solid line through all those points then. Okay, perfect. And then that inequality symbol, is that less than or equal to or greater than or equal to? It's less than or equal to. So should you shade? You should shade below or above the line. Below for less than. Yeah. So lightly shade below your line there. You don't have to go too crazy, just enough to get the idea. And then you got to solve the other equation for y, Trey, so that you can then graph it. Okay. When Sierra comes back, you can go. Yes. Let's go over this one then. Okay, let's see how we did. So, I didn't do any of it because I'm going to have some folks help me out here, all right? So, when Sierra comes back, sorry. All right, let's see here. Let's go to Aaron. All right, so Aaron, let's do this one. This one. This one. Come on, Aaron. You can do it. What's the y-intercept, Aaron, for the second equation? Or inequality, I mean. -2. You got it. So on the y-axis, -2 is right here. Right? And then, Aaron, what's the slope right here? Yep. So up one, right one, up one, right one, up one, right one. And what kind of line are we going to draw here? Solid or dotted, Aaron? You got it. See? You did much better than you thought you were going to do. So solid line. You completely guessed. Wow, you should go play the... Oh, you did? Okay, so then thank you for admitting that. So, I'll come get it here, yeah. All right. Yes. Oh, that's good. Isaiah actually wanted me to sign his yearbook, so I'll sign it too later. But not
Sign your name in there.
I will. He's asked me to, so I will sign it. I'll say, Dear Isaiah, please don't leave your yearbook in my classroom. Love, Mr. Wade. All right. So, Aaron, this is solid.
Aaron just left.
He did. Oh, for the bathroom. Well, anyway. When he returns. All right. So, anyway, there's our border line. Okay. And so we are shading above or below here. Anybody? Below because of the less than symbol. So I'm going to lightly shade here. And I'm going to do it lightly because I got to see where they're going to overlap, right? Eventually here. So I'm going to do it very lightly so I can see where they overlap. Yes? For the second equation, yes. Yes, yep, that's what I have right there, a solid line. And then 3x plus y is greater than 5. Okay, so now we're going to do this first equation. You've got to graph that, or inequality, I mean. So, Lauren, is this first inequality in a format that we can graph? No. So what do you have to do to be able to do that? To graph it, what do you have to do? Yep, subtract. Yes, yeah, go ahead. All right, go ahead, Erica, yes. So we got 3x is greater than 5, take away 3x. Okay? And so, Lauren, what is the y-intercept of this inequality? 5. And then the slope is, -3/1. So we'll go from here, which way? So my m is -3/1. So then from here, from there, my
Go right one.
go right one.
Or go down 3.
Yeah, down 3,
Right 1.
right 1. Put a point. Down 3, right 1. Down 3, right 1. Down 3, right 1. Down 3, right 1. Or up 3, left 1. And up 3. Oh, I ran out of space, so I won't do it that way. Great. Thank you. Let's go to Eric. Eric, is this going to be a solid line or dotted line here?
That one?
Yes, this one right here.
That's going to be a dotted line.
Very good, Eric, because it doesn't have the equal to there, right? So we will dash, dash, dash right through. Okay, just like that. Very good. And let's see. Caitlin, what inequality symbol is that? Y is greater than 5 minus 3x. So because we want to do greater than, should I shade above or below my line here? Above. You got it. So we'll shade above. Okay, so where's our region? This is the region right here. Okay, just like that. That's our region, where our solutions are. Okay, the region will include this border as well because it's a solid line, but will not include this border because it's a dotted line. Okay, so it's the region plus our border line right there. Okay, Aaron, you left before I get a chance to answer your, well, not answer your question, but to help clear things up here. With the inequality symbol, Aaron, if it has no equal to, right, there's no line underneath, it doesn't have an equal to, then that means it's dotted. Okay, the equal to, solid. Okay, because you're including the line. All right. Ooh. Frank, you guys said that one. Questions? Yeah, go ahead. All right, flip the paper over. All right, free response questions. Our favorite word problems. Okay. That's a weird set of directions there. I guess that goes to this question. Okay, anyway. In 2015, the social media site MyFace had 400 million active accounts in the U.S. Each year after that, the number of accounts is predicted to fall by approximately 40 million accounts per year. The same year, Instapic had 100 million active accounts. However, their membership is predicted to increase by approximately 50 million accounts per year. Okay, so we're going to write an equation for each company, and we're going to define our variables. Okay, so what are our variables going to represent here, Sky?
The variables will represent the billion people, or billion accounts active.
Okay, so we'll say that's like our y. So we'll let y be the number of accounts in millions. So the y value is going to be in millions. All right, and then we'll let x be the number of what? So we don't know the number of accounts, right? But we also don't know the number of what else is an unknown amount here? We talk a lot about accounts. We also talk about what? Years. So we're going to let x be the number of years. But not just number of years, because where do we start counting from? 2015. Yeah, so it's number of years since 2015. Okay, we want to keep that in mind, right? Especially because we started counting in 2015, so x is going to be just number of years since 2015. Okay. So now we're going to write the equations. All right, so for MyFace, each year after that, the number of accounts is predicted. So MyFace had 400 million active accounts, and then each year after that, after 2015, the number of accounts is predicted to fall by approximately 40 million accounts per year. How would I write that here for MyFace then? It has 400 million in 2015, and then it's predicted to decrease or fall by approximately 40 million accounts per year. So yeah, we're going to subtract. Okay, what's going to be subtracted? 400 minus what? 40, yeah. But it's per year, so it's going to be 40x. And that will give us then the total number of accounts for MyFace. Y equals 400 minus 40x. You got it, Trey, exactly right. Now, Instapic, in the same year, had 100 million active accounts, and they are predicted to grow by 50 million per year. So what would their equation look like? They started with 100. 100. I'm going to do 100 because we're in millions here. And then we're going to increase by 50 million accounts per year. So plus 50x. Yeah. And that's y equals that. Okay. So there are my variables defined up there. And then there are my equations. Some of you maybe think about the equations before you then think about what the variables mean. Some of you guys can like read this and just know, oh, it's going to be 400 minus 40x and 100 plus 50x. Okay. Please make sure that you do write an equation though. So it should be, you should have equal signs in your equations there. And then please make sure you define your variables. Okay. Believe it or not, sometimes that's worth points, right? If they ask you to do it, there's a good chance it's worth points. And so you might get something just for knowing that, oh, my unknown amount is years, my unknown amount is number of accounts in millions. Okay. Letter B, during what year will do the two companies have the same number of registered accounts? Show your work. All right, so we have to show our work here. So probably using our graphing calculator is not an option. So graphing these is out of the possibilities. What other method could we use here to solve this? Okay, table you said? You could make a table if you wanted to. That's one option. What else could we use? What other methods do we have? This is a system of equations. What other methods do we have? Substitution. Okay? What we'll do then, since this is equal to y, I'm going to plug 400 minus 40x in for this y. So we'll say 400 minus 40x is equal to 100 plus 50x. Okay? And now we'll just solve for x. I will add 40x to both sides here. Get the x's together. That's 90x. Subtract 100 from both sides. And we get 300 equals 90x. And I'm going to run out of space, so I'll do up here. And then divide both sides by 90. X is equal to 30 divided by 9. What's that? Yeah, you can. Yeah, sorry, I did. It's like 3.3 repeating. 3 1/3, exactly right. Okay, and remember, x is number of years. So during what year will the two companies have the same number of registered accounts? 2018. Because where do we start? 2015, and we're going to add 3.3 years. So 2015 plus 3.3 gives us 2018.3 repeating. So in 2018, they will be the same. Okay? In 2018. What's that? April? Yes, 4 months in. Yep. Like probably at the very start of April. Yes. Yes. Or very end of April, yes. Anyway. During what year is the company MyFace predicted to not have any more registered accounts? Show your work. Okay, so how can we show that? During what year? So that means we're solving for x. So what year? That means x equals what? Is the company MyFace predicted to not have any more registered accounts? So that means how many accounts will they have? If they have none, that means they have how many? What number? 0. Yeah, 0. So MyFace will just say equals 0. So we'll say 0 equals 400 minus 40x. Okay? And then we just solve this. Okay? So, let's go Kaylee. What would we do here to solve this equation here, Kaylee? What? Okay, you want to add 40x to both sides? We can start with that. So we get 40x equals 400. And then to get the x by itself there, Kaylee, we're going to... Sorry. Divide both sides by 40. You got it. So you get x, well, that's going to be 10, right? So 10 years, but remember it says during what year? So 10 is the number of years. What year will we be in? 2025. Okay? Because again, it's 2015 plus 10, so 2025. Okay? Okay. Question? Yep, go ahead. Okay. What is the domain for my face in the context of the situation here? What's the domain? Remember, domain describes the x's. Domain first, alphabetically. Range comes second, alphabetically. X comes first, and then y, right? So domain are the x's, range are the y's. So domain describes the x's, and remember the x's are the years here. So Jackson, think of an answer for us?
What would the x's be?
Yeah, what would the x's be? What's the lowest x value we would expect here if we're talking about a number of years?
Oh, the 15.
So, well, number of years, though. So not the actual year, just number of years. What's the lowest number of years that we could, like, be talking about here? We would start, well, 1. I would say even, you probably talk about 0 for just for the start. So I'd say 0. So 0, include the 0, and then up to, what's the farthest we can go? Well, this is for my face, right? So we know when my face runs out of users. So my face runs out of users after 10 years. So what's the farthest x value we can go? Is 10, right? Because we can't have no users, right? And then what's its range? Well, the lowest y value you can expect here is 0. And what's the highest y value? Well, where does my face start? What's the highest y value that my face has? It starts at 400, right? And it decreases from there. So we'll put 400 then for the range there. Okay, because that's the highest. It starts at 400 and just goes down from there. Okay. How about Instapick? What's the lowest number of years we can talk about for Instapick? Probably 0 again, right? But does it look like Instapick is going to run out of users? No, it's going to keep going. Now, I'm going to put infinity here, but that really is not true because, I mean, certainly at some point you'd run out of people, but of course you could also say, well, Mr. Wade, you can make multiple accounts. I mean, some people make accounts for their dogs and stuff. But even at some point, the servers would like run out of like space for all those accounts. But we'll say infinity just because, you know, I don't think you really otherwise a decent answer there. Okay. What about the range though? Again, what would be the lowest number of accounts you could possibly have? It would be 0 again, right? And then of course, then for the upper range, well, they keep going, so it's going to be infinity for them. Okay, but again, understanding that certainly there is a limit to the number of accounts.
Is it 0 or 100?
Oh, I see what you're saying. You're right, because we started 100. Thank you, Alex. My bad. Thank you. Yes, 100 is where we started, and we're going up from there. So it would be 100. You're right. Thank you. Yes, go ahead. Okay, so 100 to infinity. All right. Questions on any of that? Okay. So that's a little bit of review of systems. Let's see here. I've got some other stuff for us here. So I'd like you guys to go ahead then and work on some multiple choice questions I've got for you. I got 4 multiple choice questions for you. I'd like you to just work through again. It's kind of like mixed practice here, and we'll go over them. Some of them you might be able to get done in like 2 seconds.
Oh, good.
Some might take 4. What was your question? For these, sure, if we need to. 1, 2, 3, 4, 5. Okay, I'll give you a couple minutes to work on this. Okay, if you want to move around and work with some other folks, you can. But I'm going to give you like 5 minutes or so to work on this. If you want to go work with someone else, you can for 5 minutes. And we're coming back together here, okay?
Don, can you bring me a paper?
Okay.
I'm passing them down. Thank you, sir.
90 minutes. Very exciting. 10 more minutes of that. How do you get so lucky?
Which choice were you doing?
Hey, we already did this.
What?
We did this problem already.
Which one?
The sunglasses.
Well, all right, we'll see if you remember the answer then.
I already do.
All right. Some people might not remember. I never did in the first one. Okay. It's in the back corner. So it actually is like. I think we'll like you guys are on the festival
There'll be two for each one. Actually, no, this is
So you'll still eat. Yeah, you'll still eat. No, there's me too. I'll let you know what happens and stuff. Tomorrow. It'll be just our size. Maybe we can like take a field trip to go see what it is tomorrow. You know, we'll line up. Yeah, exactly. Yes, my voice is off. My voice is off. Platforms you can hear.
we only have a few hours.
Graduating. Oh my God. What are you gonna do?
I finally made friends. Oh.
I have so many videos that I didn't know I took. But, you know, I can't have my
Have you guys ever met before? You guys did like kids or accidents or anything like that?
No, just take my
Yeah, well, yeah, it's happened.
This was the one that came from
How?
Really?
Yeah, no,
You remember? Wow. So, let's just guess. Okay, so he's the former perimeter. I have the width. I have the very which, well, I mean, I'm not saying it's easy, I'm just saying it's been a while. I'm trying to say it's been a while since I've done this. Well, ideally, you practice a lot of it. For example, we learned like about lines back in like September, October, but then we didn't use lines. System.
I can tell something that's going on.
Oh, we didn't put them in order, John.
Find the one that's solved with L correct.
No, Brady did. That was Brady. Brady did.
Both sides are getting L by itself. Do you agree, Willie? Scratch the both sides. Sure, why not? That is a problem.
Oh, grab it. It is so
Not by 2 L, like divided by 2. Divided by 2. That's what table, okay, that is currently a function, right? What you're going to see then is A, B, C, D, E, F, okay? So which one of those numbers, when you put them in the blank cell there, right, when it's empty, which one of those will make this thing not a function? And if it's not a function, that's not an answer. Okay? How do you know, right? So remember that functions we want to pass the vertical line test, right? When we draw a vertical line through our function, we only want to hit one point, right? Try to do good. Yes? So here's the thing. We go back. The definition of a function is that every x value is paired with only one y. Okay? So for example, if I use b, if I said if I put -1 into that empty spot,
I don't know what to do about
it's
this.
about -1 is paired with 5, then -1 falls between 3, not a function. Which one will make it a function?
Yeah.
So -1 is not an answer because it will make it not a function. -5 is an answer.
To be honest, I'd rather have this fruit.
Okay, folks. Let's take a look here at our work. Okay. All right. What's that?
I did that one.
All right. Hey, that's better than nothing. But we'll see. And if you need help, we can go over that too. You're just not sure. That's fine. All right, girls, can you come back up to your seats, please? Just I want you to be able to see as the chorus and all that jazz. So, all right, number 1.
Wait, Mr. Like, has only this before. Can I go down to the office?
Like to leave, you mean? Well, but then talk to them. Which office are you going to go to?
The main office.
Okay, like to talk to an administrator or something. You can try, but there's a very good chance they're going to be like on bus duty or something like that.
Mr. Ball took my phone, and then I was supposed to get it back, but I had to go to the parents.
I see.
Figure out who had it.
Oh, I see. Well, do you know where she would be right now?
We tried tracking her down and everything.
Oh, she's like not in her. Oh,
No, they can't walk.
I see what you're saying. All right. Why don't you? I see what you're saying. Well, all right. All right. Let me make a phone call here once I finish going over this real quick. All right. Yeah. All right. So, cost to manufacture X pairs of sunglasses can be represented by a function C of X. If it costs $398 to manufacture 4 pairs of sunglasses, which of the following is true? So, what is our answer here? A, B, C, or D? It is C. So you actually did more work than you needed to there, okay? The cost to manufacture X pairs of sunglasses. So cost C of X. If we want to manufacture 4 pairs, that goes in for X, right, for 4. And then the cost is $398, so that would be equal to $398. You didn't need to divide it by 4 there, okay? You found the cost per pair of sunglasses, but not the total, which is all that was the total. All right, number 2. A random sample of 200 teenagers participated in a taste test. Each teenager sampled 4 choices of fruit drink, A, B, C, D, and then were asked to pick a favorite. The table shows the results of the taste test. Shh. Okay, so let's see. Based on the information given, which of the given statements are true? So like all that apply. 40% of the participants were girls. Let's see here. 80 girls total out of 200. 80 divided by 200. 0.4. A is true. Okay. 70% of the participants preferred A. Well, 70 total people preferred A, but that's 70 out of how many total? 200. That's not going to be 70%. It'll be 35%. Okay? Shh. So not B. Shh. Listen up, folks. Letter C. Shh. 20 out of 120 of the boys preferred D. Well, so there were 120 boys, and 20 of them did prefer D, so that's correct. You were right. Letter D. 10 out of 35 of the participants who preferred B were girls. Okay, so there were 35 people that preferred girls, and then, there were 35 people that preferred B, and then 10 out of those 35 were girls. So that is correct, too. It's letter D. Okay? All right, turn over there. Now, this one, the formula for finding the perimeter P of a rectangle with length L and width W is given here. Which formula shows how the length of a rectangle can be determined from the perimeter and its width? So in other words, solve for L in terms of P. And the answer is going to be B here. Well, that's a good guess, but I want to make sure you know how to do it. So I'm going to show you here real quick. Okay? You'll notice here all of these are solved for L. So we're going to solve this equation here for L. I'm using a cursive L here just to make it stand out so it doesn't look like a 1. We'll subtract 2W from both sides. Okay? We'll have P take away 2W is equal to 2L. And then divide everything by 2 to get the L by itself. We'll have L equals P minus 2W all over 2, which is letter B there. Okay?
Can we do more like this?
We will see here. I'll see how much more time because I want to make sure we do the online stuff tomorrow. Jerome is constructing a table of values that satisfies the definition of a function, input and output. So remember, it says select all that apply here. So which one of these numbers make this thing a function? Well, -5 works, right? It does not repeat, so -5 is an answer. B, -1, it would make it not a function because -1 would go to 5 and 13. So not B. Not C either because, again, the 0 would be -9 and 13. D works. Okay, E, 11, nope, it repeats. It goes to -11 as well. So, oops, not an 11. And then 17 does not work either. So it's A and D there. A and D. All right. Any other questions for me here? All right, we'll stop there then. All right, just because we have 5 minutes left. All right, let me make a call here to Miss Harding at least and see. For Kaylee.